Hello students, here it is a question paper, January 23rd, afternoon shift and 2023-2026 JEE examination. And the paper is moderate to little bit difficult oriented question paper, and it is straight away from the NCERT, many questions has been asked. So let us see the first question of the day. Here it is, a cell is given and two compartments, and one compartment C2 concentration, another compartment and C1 concentration. Here consider the above electrochemical cell where a metal electrode M is undergoing redox change by M gives rise M plus an electron, and the cation M plus is present in the two different concentrations C1 and C2 as shown in the diagram. Now, which of the following statement is correct for generating a positive electron? That is going to be a very important component. This is the key point. We know that EMF of the cell is equal to E naught minus 0.0591 by N. So, log anodic concentration and cathodic concentration. Now, if we take this, EMF is equal to E naught plus 0.0591 by N, cathodic concentration upon anodic concentration. If we want to take E naught is cell positive, the cell EMF is positive, that is possible only concentration of cathode is greater than concentration of anode. If that is the case, C1 is greater than and C2. The option for this question is going to be option 3 is the correct answer for this question. And there are two statements, there are 4 statements are given in this question. It is based on mix matching question. Identify the incorrect statements from the following. And notation of 2412 magnesium represents 24 protons. No, this 24 indicates the mass number. So, there should be 12 protons and there are supposed to be 12 neutrons, so that it is not correct. And wavelength of a radiation with a frequency 4.5 into 10 raised 15 second inverse is 6.7 into 10 raised minus 8 meters. So, we can use C is equal to nu lambda. By using this formula, you can calculate this wavelength, and it is supposed to be correct. And when it comes to one radiation with lambda 1 900 nanometers, lambda 2 is 300 nanometers. And it is going to be, the energies is going to be 3:1, as energy is inversely proportional to lambda. So that it is supposed to be 3:1, not correct, and it is supposed to be 1:3 is the answer. So this is not correct. And number of photons of a light having wavelength 2000 picometers that provides 1 joule of energy is going to be 1.0006 into 10 raised 16. So, energy is equal to NHC by lambda. If you put this N values are supposed to be getting this, and this is correct. Now, look at this. It is asking about the find out the incorrect statements. I found A and C only the incorrect. So, answer is first option is the correct answer for this question. Children, this is a very famous question from the complex compounds. It is all asking about inner orbital complex or outer orbital complex. So, whenever it is comes to the inner orbital complex or outer orbital complex, a weak ligand is there, it uses outer orbital complex. For coordination number 6, it is going to be sp3d2 hybridization. When it comes to the weak ligand, it is generally you can say halogens are the weak ligands. But strong ligands like ammonia and cyanides, you can say inner orbit, they are strong ligands, so that inner orbitals are going to be used. So, in that case, D2sp3 is going to be the hybridization for coordination number 6, and DsP2 is going to be for the coordination number 4. So, let us see here, cobalt is going to show +3 oxidation state, it is going to be D6, and manganese is there, manganese it is going to be 3+, it is going to be D4, and cobalt is there, again 3+, it is going to be D6, and iron, in this case iron +3 is there, here going to see +3 oxidation state is going to be D5 configuration, and nickel 2 plus is there, it is going to be D4 configuration. Let us see here, ammonia is a strong ligand, so that it is going to be inner orbital complex is there, and manganese with chlorine, weak ligand, outer orbital complexes will be there, and cobalt with fluorine, it is going to be weak ligand, outer orbital complex is there, and iron with fluorine, again it is going to be outer orbital complex, and nickel with cyanide, it is going to be strong, so that inner orbital complex is seen as coordination number 4 square planar complex, it is going to be DsP2. So that in this case I can say A and B and D can show the correct match for this. Option 2 is going to be the correct answer for this question. NPAS. Children, here it is a logical question based on group 15 elements. You can also compare with the periodic classification of elements. Elements X and Y belong to the group 15, and the difference between the electronegativity of X and the phosphorus is higher than that of the difference between phosphorus and Y, and X and Y. So, if you check the electronegativity values of this, nitrogen is greater than, phosphorus is greater than, arsenic is greater than antimony. So, it is given as less than phosphorus and greater than phosphorus. So, it is supposed to be X and it is supposed to be Y. So, X is going to be nitrogen and Y is going to be arsenic. It is a simple logic oriented question, and the answer for this question is going to be option 4 is the correct answer. Children, this is the question based on transition elements, important compounds of D block elements. It is going to be the oxidation state of chromium in the final product in the reaction between Ki and acidified K2Cr2O7. So what happened? K2Cr2O7, Cr2O7 react with potassium iodide in the acidic medium. It is going to give rise Cr3 plus and I2 and H2O is formed. So that chromium shows here +3 oxidation state. For this question, option 1 is the correct answer for this question. Children, here is a question from this periodic classification of elements. So, given two statements are there. The second ionization energy of the sodium is larger than that of corresponding ionization energy of magnesium. Yes, once the sodium is lost one electron, it get stable nearest noble gas configuration neon. So that always remember, ionization 2 of the group 1 elements is greater than ionization energy of the group 2 elements. So that statement 1 is correct answer for this. And statement 2, the ionic radius O2 minus is always larger than F minus. So radius is directly proportional to the negative charge. Therefore, this statement 2 is also correct. So for this question, option 1 is the correct answer for this question. So moving ahead, the another question it is, which of the following statements are true about haloform reaction? So in every session, most of the sessions based on haloform reaction, the questions has been asked. So which of the following statements we have to find the true about the haloform? So sodium hypochlorite NaOI NaOI react with the potassium iodide, it is giving rise to NaCl plus KOI. Yes, it is correct. KOI is a reducing agent, wrong. It is an oxidizing agent. And alpha beta unsaturated methyl ketones will give iodoform test, and it is a correct statement. So anything has this can give iodoform test. Isopropyl alcohol will not give iodoform test. Isopropyl alcohol CH3 secondary methyl alcohol gives rise iodoform test. So this is iodoform test will be given. And methanoic acid will give positive iodoform test. Methanoic acid will not give positive iodoform test. The correct answer, I can find the true statements this one and this one, A and C only. The answer for this question is going to be option 2. Here is a question from the ethers. A mixed ether P when heated with excess of hot concentrated hydrogen iodide produce two different alkyl iodides. Reaction with HI, it is given in the NCRT, you can use that concept. So, this when treated with aqueous sodium hydroxide gives a Q and R, both Q and R gives yellow precipitate with NaOI. So, they give the Iodoform test. So, if you consider this, so when it is given with hydrogen iodide, it is going to give you OH plus it is. So, both the compounds can give Iodoform. So, therefore, I would like to say this is the correct answer. We can cross check it with this. You are going to say here and you are going to see the various forms. This cannot give Iodoform test, right? So, like that you can also say here, and the compounds once you break here, you are going to get the products and you are going to see the Iodoform test. So, the answer for this question is going to be option 1 is the correct answer for this question. Children, this is the question based on the carbocation stability. You have two types of carbocations. Here, statement 1, methyl carbocation, trimethyl, so tertiary, so there are two carbocations, tertiary butyl carbocation, CH3 and CH3 and CH3 and methyl carbocation, this one. Of course, this is more stable because hyperconjugation is going to be more because it has more number of alpha hydrogen. Stability of carbocation is directly proportional to number of hyperconjugation structures. Here the number of alpha hydrogens indicates the number of hyperconjugation structures. In this case, I can find here it is the 2, 3, 3, 3, 9 alpha hydrogens are there. So that 9 alpha hyperconjugation structures are there. So that I can say here the statement 1, it is true. While in the case statement 2, CH3 plus is less stable than CH3 thrice plus has only 3 hyperconjugation structures. Of course, methyl carbocation is less stable, it has 0 alpha hydrogens, has no hyperconjugation. So that it is indicating that it is a hyperconjugation, the statement is absolutely wrong. I can say statement 1 is correct and statement 2 is not correct. Option 4 is the correct answer for this question. Children, here are the two equations are given and statement 1 and statement 2. Let us see. Statement 1, this compound can be synthesized from that particular compound using a simpler reagents in the order acetic acid, KMnO4 and ammonia, bromine and alkali. So, directly we can write in this way. So, if you use KMnO4, if you use KMnO4 here from this compound, if we use KMnO4, you are going to get any alkyl benzene is going to give rise the corresponding benzene carboxylic acid as long as a pi bond is present on the benzyl carbon and there is a benzyl hydrogen. Now this is heated with bromine and alkali. So you are going to see ammonia and you are going to see bromine and heat it, you are going to see this. So, amide will be formed, it can be decarboxylated. So, this statement is correct. While this compound can be converted into this by using a suitable reagents like, so if this is amino group and methyl group, you just see the bromine in water, you can use bromine in water. Ammonia is an electron releasing group, so that bromine is going to be attributed to its respective ortho and para positions. Para is blocked, so amine group is activating, so ortho brominated. Now NaNO2 HCl diazotization, you are going to get diazo compound N2Cl and it is going to be Br and Br and CH3. And later on aqueous H3PO2 diazo group is lost. You are going to see Br and Br and CH3. So we got the product, and this statement 2 is also correct for that. So the answer for this question is going to be both statement 1 and statement 2 are correct answer for this question. Children, here it is question based on the Carius method, practical organic chemistry, grade 11. Every session from the Carius method or the any other methods, practical organic chemistry, estimation of elements are given. So in Carius method, 0.2425 gram of organic compound gave 0.5253 gram of silver chloride. Percentage of the chlorine can be calculated as 35.5 upon 143.5 into weight of AgCl upon weight of organic compound into 100. Directly you can plug this formula. So that is going to be 35.5 upon 143.5 into weight of AgCl. So Carius method 0.2525 gram, 2425 gram of organic compound, mean to say 0.2425 gave 0.5253 gram of silver chloride. So on solving, you are going to get percentage of chlorine is going to be 53.58 percentage will come. So that option 1 is the correct answer for this question. Children, here is another question based on benzene sulfonyl chloride and amines chapter, and a student has been given a compound X whose molecular formula C6H7N. C6H7N. So let us consider this as aniline. You can say this is X, and it is sparingly soluble in water, of course. However, on addition of dilute mineral acid, X becomes soluble in water when X is treated with CHCl3 and KOH. CHCl3 chloroform in KOH, it is going to get phenyl isocyanate, and it is a KOH. Y is produced, Y has a specific unpleasant smell. All isocyanates has specific unpleasant smell. So it is correct. And treated with benzene, so this is going to be Y. When treatment with benzene sulfonyl chloride X gives a compound Z. So benzene sulfonyl chloride C6H5SO2Cl, benzene's Hinsberg reagent. It is going to give a compound soluble in alkali. So that is going to be SO2 NH SO2, okay, C6H5. So in this is the compound, and this is soluble in water because you have a proton over there. So the question is asking the number of different hydrogen atoms present in the compound Z is. You can see different compound hydrogens means it is a type of hydrogen. It is a type of hydrogen, and here are the types of hydrogens. So I can say 1, 2, 3, 4, 5, 6, 7. So I can find 7 different types of hydrogens are present in this. So option 1 is the correct answer for this question. Students, here is the easiest question from the biomolecules. So both human DNA and RNA are chiral molecules. Yes, the nucleic acids are chiral. The chirality of DNA and RNA arises due to the presence of DNA and RNA composed of a phosphodiester linkage between a base and the sugar. And you can see this base, nucleic acid base, is connected with sugar, and it is going to be phosphate. And this has a nucleophilic nucleotide basic structure. What is this D sugar, D ribose? Because of this D ribose, it is going to be optically active. So it is a chiral molecule, so D sugar component present in this. So option 1 is the correct answer for this question. Moving ahead, one more question. It is noticed that Pb2 plus is more stable than Pb plus 4. So the key is given in the question itself due to inert pair effect. And but SN2 plus is less stable than SN4 plus. So SN4 plus is more stable. So observe the following, the question key is given. So PbO2 gives rise Pb plus. So it is plus 2 and it is plus 4. So the driving force is going towards the instability. So the process is going to be non-spontaneous, delta G is going to be positive. And SnO2 plus 4 and SnO it is going to be plus 2. So for this process is going to be the driving force is going to be positive. So I want to say identify the corresponding side of this, and I want to say it is going to be reaction 1 delta G is less than 0, reaction 2 delta is greater than 0, because it is going to be negative, it is a spontaneous process. It is a spontaneous process because it is going to be a spontaneous process because Pb2 plus is going to be more stable. So the driving force is going to be in the more stable state. Children, here it is a one more question. This is the compound. In this compound is treated with the zinc and HBr is a second version of this reaction. So the reaction takes place in 2 steps. So what would happen if it is treated with the zinc first? So it is going to form its corresponding alkene like this. Now it is treated with HBr. You are going to see H plus and a carbocation can be formed here. A carbocation formed here. So carbocation formed in this and as well as in this. If it is formed here, it can be rearranged to give rise more stable carbocation. And this is more stabilized by more number of hyperconjugation, and you are going to see when Br minus is added, you can get this. So the appropriate answer for this question is going to be option 3 is the correct answer. Children, here it is a question from chemical kinetics. So observe the following reactions. A gives rise to product. So and 5Br minus plus BrO3 plus 6H plus gives rise 3Br2 and 3H2O. Both the reactions are started at morning 10 a.m. The rate of this reaction conditions at 10 a.m. is given as minus delta Br minus delta T. So according to this one, I can say the rate is equal to 1 by 5 dBr by dt is going to be, and here what is the first order rate constant? The question itself says this is first order rate constant. K is going to be a to the power 1. So at that time you are going to say at 10 a.m. So you are going to see 1 by 5 and this value is given as 2 into 10 power minus 4 is equal to K, and A concentration is given as 10 power minus 2, and you can write it is 10 power minus 2 power 1. On solving K, you are going to get 4 into 10 power minus 3. So the answer for this question is going to be option 1 is the correct answer. So follows first order constant. The question is very simple, and this particular equation given directly from the NCERT, and the question revealed that it is the first order kinetics. So the answer for this question is going to be 4 into 10 power minus 3. Children, this is a question from Iodoform test. Every session in January 2026, many questions are repeated based on Iodoform reaction. You can see Iodoform test can be differentiated between. So what is the condition to give rise Iodoform test? It could be at a methyl ketone or it could be with secondary methyl alcohol and it could be with ethyl alcohol. So these are the 3 cases where you can see the formation of the Iodoform reaction. So methanol and ethanol it will give, and acetic acid and propionic acid, carboxylic acids are not included. Cyclohexene and cyclohexanone, it will not be. And diethyl ether pentan 3-one cannot be. So anisole and acetone can be. So I want to say A and E can be given, A and E only can be given by the iodoform reaction based on these particular experimental conditions. Children, here it is a question basically from the photoelectric effect from the structure of atom. You can also take the advantage of this physics in this. So work function of two metals are given Ma and Mb. So are as a 1:2 ratio. When these metals are exposed to the photons of 6 electron volts, and the kinetic energy liberated electrons has Ma and Mb, and the ratio is 2.642:1. So the work function of Ma and B, metal A and B is given. So according to Einstein photoelectric equation, it is given as energy of the incident photon is going to be work function plus Ke. So the Ke is given, that is the energy minus work function. So I can say Ke of A and Ke of B is equal to. So I want to say this is a work function, it is given as 6 minus this energies, it is going to be 1 and it is going to be 2. So that ratio is given in the ratio of 2.641 upon 1, and on solving that E1 you are going to get, E2 you are going to get as 2.3, and it is going to be 4.61:2 ratios. So I just want to say option 2 is the correct answer for this question. Dear children, here is a question. There is a concentration versus time. The experimental type study is given. Given above the concentration versus time plot for the dissociation reaction, A gives rise n moles of B. Based on the data of the initial phase of the reaction at 10 minutes, the value of the n is going to be. So you can say when time is equal to 0, it is going to be, the concentration is going to be 0.05. A is given, it is not started. Now when time reaches to its time, it is given 10 minutes. So 0.05 minus x, 0.05 minus x, it is going to be nx. So the total number of moles that you are going to see, 0.05 minus x is going to be how much I am getting? 10. It is going to be 0.04. So x you are solved to be 0.01. So it is seen that nx is going to be 0.03. It is going to be 0.03. So on solving x, I am going to get is 3. Answer for this is going to be option 1 is the correct answer for this question. Children, this question is based on VSEPR theory and group 18 elements, xenon compounds, P block elements and grade 12. So you can interrelate with 11th standard topics and 12th standard topics here. Which statement is not true? So we have to take the catch point before you answer this. About XeO2F2, XeO2F2. So that is missing here. Okay, let me write that. So what is the actual shape of XeO2F2? It has one lone pair of electron and it is going to be equatorial positions and oxygen, and it is a fluorine, and it is a seesaw shape. It is a correct statement. So Xe has 5 electron pairs in its valency shell. So you can see the electron pairs as a double bond, it is not actually correct. So it is superoctet compound, and the XeO bond angle is going to be 180. Here it is not shown as 180 because these oxygens are present at equatorial positions. So I just want to say here it is also not correct. But XEF bond angle nearly looks like 180. You can say this is a correct statement. And Xe has 16 valence electrons. You can check it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 14 electrons are there but not 16. So it is also wrong. So I can say B is wrong, C is wrong and E is wrong. So option B, C and E are the wrong statements as far as the XeO2F2 is concerned. Children, here is a numerical type question where you can see x2 plus y2 gives rise to z. X2 and Y2 are added to 1 liter flask and found to that system attain at equilibrium. So there is an equilibrium system. So K equilibrium is going to be Z square upon X2 and Y2. At a temperature T Kelvin, number of moles of X2 and Y2 and Z2 are 3, 3 and 9 moles respectively. I want to say 9 square upon 3 into 3 is going to be 9 only. So the K equilibrium constant, you got it. Now, under this condition, the equilibrium 10 mole of Z are added to the flask. What would happen if this X2 plus Y2 gives rise to Z? So the equilibrium is saying under these conditions of equilibrium 10 mole of Z is added to the flask. So that what will happen, initially 3 was there, it was initially 3 was there, if X is added here 3 plus X and it is going to be initially 9 was there and if you add 10 it will become 19 minus 2 X. So if you write the K equilibrium constant it is going to be 19 minus 2 X square upon 3 plus X and 3 plus X. On solving X is equal to 2 and 19 minus 2X is equal to Z. So Z is equal to 19 minus 2 into 2. You are going to get this value as 15. So the answer for this question is 15 is the answer for this question. Dear children, here it is a question directly coming from complex compounds. The number of unpaired electrons present in the central metal, nickel tetracarbonyl, nickel tetrachloride, so PtCl2 NH3 twice, nickel tetracyanide 2 minus and PtCN4 2 minus. Let us talk about nickel tetracarbonyl. It is going to be sp3 hybridization, N is equal to 0. And when it comes to nickel tetrachloridone nickelate, so it is going to be sp3 hybridization, N is equal to 2. Here it is going to be platinum, you are going to be dsp2 hybridization, N is equal to 2. Here it is going to be sp3 hybridization, N is equal to 0. So I can find it is also going to be dsp2 hybridization, N is equal to 0. I could find only N value is 2 in the sum of the all compounds. So the answer for this question is going to be 2 is the answer for this integer question. So consider the following reaction. It is given benzene is with some carbonyl compound with acid chloride. It is going to give a compound P and this is reacted with sodium hydroxide. Intramolecular aldol condensation reaction takes place. And the percentage of oxygen in this particular compound. It's really important. And nice example here, whenever it is reacted with acid chloride, this acid chloride is going to get a compound like this. So P is going to be like this. So it is going to be C double bond O and CH2 and CH2 and C double bond O and CH3. Now this is a alpha hydrogen. This alpha hydrogen is going to attack here. So this intramolecular aldol condensation takes place. As a result of this, you are going to get a compound like this. and the molecular formula and the molecular mass is going to be 158. This molecular formula is going to be 158. So the percentage of oxygen for this compound is going to be 16. Only one oxygen is there, no? Into 158 into 100. That gives you appropriate answer, as the answer is going to be just 10%. You are going to see answer for this question is 10 for this question. Dear children, this is the question based on this vapor pressure and Raoult law. What Raoult law says? Partial vapor pressure is equal to P naught A mole fraction of A. Similarly, Pb is equal to P naught B mole fraction of B. Now read the question. Two liquids A and B form an ideal solution. Yes, so we can use the Raoult law. At 320 Kelvin, the vapor pressure of the solution containing 3 mole of A and 1 mole of B, so is 500. So that Pt is equal to Pa plus Pb. So Pt is equal to P naught A mole fraction of A plus P naught B mole fraction of B. So it become 500 when P naught A and you take this 3 mole of A. So containing 3 mole of A and 1 mole of B. So 3 upon 3 plus 1 is equal to 4 plus P naught B into 1 upon 4. So this is equation number 1. Further added to this solution, 1 mole of A is further added to this solution. So you are going to see another case here. It is going to be the vapor pressure of the solution increased by 20. So if it is increased by 20, so it is going to be 500 become 520. It is going to be P naught A and into 4 by 5 plus P naught B into 1 by 5, because B is kept constant. So this is equation 2, and solve equation 1 and 2 together. You are going to get P naught A is going to be 600 mmHg and the P naught B is going to be 200 mmHg. Now you see the question, the vapor pressure of B in the pure state is going to be, I am getting 200 mmHg. Option is going to be 200 for this question. Children, this is the question. 200 cc means 200 milliliters of X into 10 to the power of minus 3 molar potassium dichromate is required to oxidize 750 milliliters of 0.6 molar Morse salt solution acidic medium. Here you are asked to calculate what is X. So what is a Morse salt? Ferrous ammonium sulfate is called as a Morse salt, which contain Fe2 plus into the active ingredient. So it is going to react with the potassium dichromate Cr2O7 2 minus. In the acidic medium, you are going to get Cr3 plus and Fe3 plus and water is going to be formed. Let us calculate the N factor here. The N factor here plus 6 and you are going to get this 2 into plus 3. So together, so it is going to be plus 12. So N is equal to 6. Plus 2 is converted into directly plus 3. N is equal to 1. So number of equivalents of K2Cr2O7 is equal to number of equivalents of Morse salt. So that N into molarity into volume is equal to N into molarity into volume. So N factor is 6, molarity is given X into 10 power minus 3 and its volume that is required is 750 milliliters. 200 milliliters is equal to 1 into whose molarity is going to be 0.6 into you require 750 milliliters. On solving X is coming to be 375 milliliters. The answer for this question is going to be 375. So we did all the questions from this session, and most of the questions are directly coming from NCERT, and the outcome, what is takeaway, this paper is coming from the NCERT, and so many logics and so many twists are there. And children, I strongly recommend you follow NCERT, stick to the NCERT guidelines, and all the best for the further examinations. Thank you.